Okay. So today's topic is DBMS architecture, and we are going to take one example of one query, and we are going to deep down that how it goes through all the phases of this database architecture and gives you the output. So that we are going to understand. And for that, I need you to assume that you must have done all this already during your college also as a student. So the thing is like I want you to assume you are checking your result on your portal of your organization. Your semester end results came and you are checking it out. Suppose you have opened the portal. So this kind of application you will see, you must have seen, and there you must be getting. I'll just cover up the main things, and here you have to give your hall ticket number. Yeah, and then you have to click the submit button. That is the thing. Yeah, and then on clicking on this button, you will see this table in which your results are displayed. So that is the thing. So you will see your complete result. So within just a click, you got your result done. But what is happening, on the back end? What you never saw is what the moment you press this button, the portal on which you are working, that you have utilized to see the results, it will write one sentence in one language which is called as SQL language. So in SQL, it will write one sentence, that is structured query language. And we are going to deep down into this one also in the further upcoming lectures. And it will send that sentence in the form of a query to the further phases. So let's see what sentence it will write down. And then we will gradually understand through what phases that sentence will go, and it will give us the results. So let's see that one by one. So this is one sentence that will be generated when you will click the submit button. Okay. And here, don't worry about the syntax right now. You will learn it anyhow, and you will be writing it by yourself when you will be coming gradually to unit number 3, and it will start from the unit 2 partly only. And but what matters today is what happened next. When after clicking submit button, this query is generated to the system, and what will happen with this query, and you get your results. Okay. So that is the thing that we have to discuss. So let's see what is happening over here. So here the first thing we are concentrating on is your hall ticket. Okay, because you have given the hall ticket number, this one. And here any number you can imagine, suppose 3 as your hall ticket number I have given. And here we will target the table student. This is your table name because we are focusing on the student data. And these are the predefined syntax keywords that we are going to use. Star is utilized to represent all data from the table. Select means we are going to select it. Select is one keyword, one command of the query language. And here we are giving the condition. So this part is the condition part. This part is the condition part where the hall ticket number is 3. So the minimal I'm making you try to understand what is happening over here, and by reading also you can understand what we are going to do. Okay. So what will happen with this? In just few milliseconds, this one line will travel through the components inside your database system. This query will be checked, it will be translated, it will be optimized, it will be executed, and then your marks will pull off from disk and it will brought back to your screen. And it will all happen before you even blink. Yeah, that's the interesting part. But too much is happening on the back end that we are going to understand now with the architecture. So we are going to trace this entire journey, and by the end of this video, you will be able to draw the complete DBMS architecture and you will understand how things happen. And yes, by the way, it is a guaranteed 10 marks question in your semester end exam that you have to focus on. So let's see, this is your complete architecture, and with first look it may look complicated, but it is not that complicated. We just have to understand it step by step. Okay. So it is I will divide it into 4 floors. So the top floor, this one, top floor will be of your users, and we'll go through them one by one. Okay. So this is your top floor, this part, and this is your second floor. Okay. Then after that, this one. So from users part, we are coming to the query processor, and then we'll come to the storage manager, and finally we will have a storage, disk storage, the lowest part in which your actual data is residing. So let's go through it one by one to have the complete clarity on this DBMS architecture. Let's go. Yeah, so here is the one. Correct. So the top floor will be the users. People like you and me are the users, and we will see what are other types of users which are part of this database system. Now, the question comes here is who actually is using the database? Most of us in one thought will think like only programmers. No, that is wrong. Or I would say it is incomplete answer. So there are different types and we'll enter to them one by one. So I'll first take the first user, that is your naive users. So who are the naive users? Naive users are those people who don't even know that database exists. So these are those users who are very new to the system. Like you can imagine like your parent is booking a train ticket on IRCTC portal, and or you can imagine yourself also checking your semester results online. So you are acting like a naive user. You are not tackling with the inside technical things. Yeah, you are just tackling with the interface, application interface. So you are interacting through this interface, and what are these interfaces? They are being developed with in the form of forms, buttons, and apps. So in these forms you will see this application. So the users which are directly just interacting and utilizing this interface, they are called as naive users. The second ones are our application programmers. These are basically those ones, who develop, who build these applications. So they are the writers of these application programs. So they know inside out of these, complete program on which we are using it as an application. Correct. So they write programs on SQL embedded inside the code, and their door is, application programs. That is the thing. Now comes third one. Third ones are sophisticated users. They are the analyst. They can write SQL directly. So these are those technical people who can understand how to write queries, how to communicate with that software inside. So they use what? Their door is query tools. Their door is query tools. So what happens in this one? They don't need an app, but they open that tool, query tool, and they will type the SQL directly by hand, you know. And here is the fun part. Today, suppose you are checking your results. You are the naive user. You are acting like a naive user. But when we'll reach gradually to the part where we are learning SQL, MySQL, by ourselves, you will become the sophisticated user because you will be writing the SQL queries by yourself, and you will be using these query tools, and there are different tools available. We will be using in this course as MySQL. Okay, and one online tool that you can refer is one compiler I have utilized somewhere, and today also I will show you some queries on this tool. So that is the thing. So from starting, the users who are just using the applications, the programmers who are developers, and who are actually writers of these SQL codes, and then the sophisticated users who know to use query tools. And then comes the last type of users, DBA, database administrator, the boss, because it will create the schema, and we have already discussed what schema is. Okay, so you can see my previous videos to understand the terms instance and schemas. Very, very important for your exams also. Okay, so they will be creating the schemas. They will be controlling who can access what, and they will be, maintaining backups, and they will tune the performance. And how they will do it? By utilizing administrative tools. These are the administration tools that will be utilizing. So they will be talking in terms of definition languages like create commands. Okay, create command, change the command, that is alter command, and then grant access to certain users, what type of access is to be given. So they will be communicating in those terms. So these are different types of users. That is our first flow. on which it all starts. So let's go now to the second floor of the architecture. Okay. Yeah. So our second floor will be your what? Is query processor. So now from user floor, we came down to the query processor. So that is the thing. So our query processor, what it will do? Query processor. Now here, I need your full attention because this is the most beautiful part of the whole system because it is tackling that one sentence we started with. Select star from student where hall ticket is equals to the number, your number. 3, I think I have taken earlier. Okay. So here what will happen with that sentence? So when that as a user, you clicked on the submit button from the top floor and then that sentence will be generated. That sentence will come to the query processor. Now, what will happen to that sentence that we have to see? Now, before that, I would like to take your attention to one part. When we studied C programming, okay, C programming. So here, what we have to give the complete instruction to the computer how to do everything. How to do everything. By giving in the form of loops. Yeah. Oh, I will take you back to the previous slide. So yeah, here. So here what I was telling you, here we were discussing okay, when we studied C programming, here we have to tell how to do things. We have to tell to the tool how to do complete thing. Writing the loop, checking the condition, increment the counter, and break when found. So this micromanage every step. So we have to do everything. We have to tell everything. But in SQL sentence, it will never say how to find out. So when you are writing SQL query, the one which we are taking as an example in this architecture, it is just telling what to do. It is just telling what to do, not how to do. So basically, your SQL is a declarative language. You declare what you want. You declare the result what you want. The query processor figures out the best way to get it. So here comes our query processor. It has to find out the way to get your result. You are just telling it what to do. Okay. So you can imagine it like you are sitting in a cab and you are telling to driver just the destination and the driver knows the navigation. That what query processor is doing. I hope you are getting what we are talking about. Now let's discuss it one by one. So I'll start from this part. I'll start from this part, DML compiler and organizer. Okay, so that is the main part of the query processor. So what is happening when you are giving that query? Select star, that query that we have seen, select star from student. Yeah, where hall ticket is equals to 3. Yeah, that is the thing. So what will happen with this? It will come to DML queries. It will come from here and then it will go to compiler and organizer. Now here what will happen? Here three things will happen. DML compiler and organizer will do three things. First thing it will do is parsing. It will check whether your syntax is correct or not, whether you have written the correct spelling of select or not, whether you have kept the semicolon or not. So that is the syntax part that will be parsed here. Then second thing it will do is semantic. Okay, semantic check will do what? Whether your table is existing or not, like the table student, whether student is existing or not, it is correct information or not, whether the column hall ticket is existing or not. So that will be checked in the semantic. So that is the second thing compiler and organizer will do. Now comes the third part, and that is the magical part. Here, what will happen? Optimize. Optimization will happen. So it will translate your query into some low level code, low level representation. Okay. So here your optimizer will work. Yeah. So let me clean it and let me focus on the main part now. So what we have seen till now, it has done three things: parsing, semantic, and then optimize. So let me focus on this third part, optimizer. So what it is doing? Basically, this query optimizer will compare some plans. Okay. What plans? Suppose you have a table and this table is having 10 lakh of rows of a student data. So there are two ways to check the student data because we are targeting the student table. So one way is going step by step, one by one to all 10 lakh rows. Is it a good way? No. So there is a plan B. From this table, just target the main column. Suppose I have taken the hall ticket. So I'll just target the hall ticket column. And in this hall ticket column, it will find out that number which we have targeted. So we have directly jumped onto the column required. So that is hall ticket column. So instead of going through one by one all 10 lakh rows, we have jumped directly to the main column. And that saved a lot of time. That is being done by optimizer. That is being done by optimizer. So basically, every single time you'll press enter on any application, you are never going to see it happening that this is happening. So optimizer is choosing for you what is the best way, what is the cheapest way to fetch the data. Okay, so this is again a beautiful part, and that again depends, you know, how database people are designing the complete database system, and that's why only database people get paid well. So understanding what the optimizer does is half of the database performance tuning. Right now we have to go further. So after this, what will happen? After this, your query will go to the query evaluation engine. The chosen plan, the efficient plan that is being chosen by your optimizer will go through the evaluation, and here your query will be executed. Yeah. So now compiler decides the route. The evaluation engine is basically driving your car. That is happening over here in this part. I hope you got some idea. Now let's discuss about the pending parts of this query processor. Our next one is DDL interpreter. DDL interpreter, because why select command went to DML? Because it is a manipulation language. Okay, it is a command of your manipulation language. It will never go to this part because here definition language, only defined commands will go, like create command, alter command, grant command. They all will travel through DDL interpreter, and again finally it will go to query evaluation engine, and finally you will get the results. Now the next part of this query process is compiler and linker. Your compiler and linker will do what? It will convert your program with embedded SQL into object. So that is your object code. So it will convert it into object code, and finally it will go to the evaluation engine. Yeah. So all in all, every road will lead to evaluation engine. I hope you got some idea. So this was our next floor on which we were talking, and now comes our next floor from this where it will go. So let's go through it. So our next floor is storage manager. Now, starting from the users, we came down to the query processor where our query was being evaluated. Its syntax is being checked, its semantics is being checked, then it is being optimized, and then the query is being evaluated. Now it will go to the storage manager. Now what things will happen over here? Let's go through it. So storage manager is our third floor. So what is happening over here? So it is the interface between our upper level and the lower level. That means the actual disk where the data is being stored, and here the processor from where our query was being processed. Correct. So what it will do? Let's see. Yeah. So basically it is being discussed in 4 departments. Our first department that I'll start with is authorization and integrity. So it works like your security guard, before your query will touch any data, what happens is your query cannot access your disk directly. So it has to face the storage manager first. So what will happen here? It will only decide whether you are being allowed to access the data or not. So it will do basically 2 things. Okay. So first thing, it will first check whether you are allowed to access the data or not. If you are being given the access of only view, you can just check the data. As a student, you can only check the marks. You cannot update the marks. So that is the thing, what you are allowed to do. Okay, so that will be checked here in authorization, and then second one will be checked as violate. If you are violating any rules. So this violate thing will come only for those users who have access to update the data. So it will check the constraints, the rules, you know. So there are some predefined constraints which works like rules, and if they are being violated, you will get some warnings. That is the thing. So that is being done by authorization and integrity part of the storage manager. Then second comes as transaction manager. So let me clean it for you, and then we'll see the transaction manager. So transaction manager will do what? Transaction manager, you can imagine it like, suppose two people are sitting in two different cities. There are two people, A and B. They are in two different cities, and they both are trying to book the ticket of a train. And one ticket is available. And they both are now checking out that ticket. If within a second they both are clicking on that book the ticket, can it be done? Think about it. Just give it a thought. Just give it 1 minute, pause the video, and think about it. What will happen at that time? Will they both get access to the ticket? Can the money be deducted but the ticket not booked? What will happen? Just imagine the scenario and think about it. Yeah, so you can pause the video and think about it and come back. Yeah, so the thing is, the transaction manager will guarantee, okay, it will never happen. You know, it will ensure the properties to be followed, and it will manage what happens when hundreds of operations run at the same time. So transaction manager has to follow this ACID properties, because our database has to follow this ACID properties, that is atomicity, consistency, isolation, and durability. So it will come in full detail and deep in your unit number 4. Okay, so that anyhow we are going to discuss, so I'm not going in too much detail of this right now. Let's move forward to our fourth part of the storage manager, that is, sorry, third part of the storage manager, that is file manager. So it performs very simple job, but the critical one. What is critical? It will allocate the disk space. You know, allocation of the space on disk and maintain which data structure will be utilized. So if you have studied data structure in your previous semester, you can relate things. You know, how records will be placed in different blocks. These are data blocks. Which data will go in this, which data will be stored in this one, and which file will go where in your disk space, that will be decided by file manager. So that is a work of file manager. Now comes buffer manager. That is my personal favorite, and honestly, it is you know unsung hero of your database performance. So here what will happen is, it will maintain from where data is to be called. Okay, so what happens here is, usually we have hard disk in which data can be stored, but it is slow as compared to what? As compared to your main memory, that is RAM. So if you are fetching the data, if you're calling the data, like suppose I have written the hall ticket number is 3 is to be called and it is to be checked. And if that data is available in RAM, so it will first check the RAM. And if data is available, it will fetch the data and it will give it to you. So it will work very fast. And suppose if we are storing everything in your hard disk, then definitely your system will become slow. So that one part is to be managed by the buffer manager, and it is very critical part. And that maintenance cost and that all things is very crucial for the database and storage manager. Okay, so I hope you got some idea, and let's move towards the lowest part of our database architecture, and that is your disk storage. So what happens over here is, it works like your basement. You know, this works like our basement. So here the thing is, like, I'll tell you one by one what actually lives on the disk. There are 4 things that we are going to discuss. The first one is obvious one, that is your data files. Okay, your records that are being stored, and they are being stored in the data. Okay, second one is indices. So what are indices? That is basically the shortcut we talk about. So it maintains one index like 1 2 3. This you can directly jump to some data, one type of data, second to this data. So it works like your book index. So suppose you want to jump to some certain page 200. Okay, so instead of reading the whole book, database indices will give you the fast access to some specific records. So that is the work of indices, you know. Okay, now next one is the surprising one, that is your data dictionary. So it maintains your metadata. What is metadata? Metadata is data about data. Okay, so to remember this one, you can remember one definition. It is the database about the database. The funny part, what is data about data? That means it maintains the complete information about your table names, its columns, its constraints, who are the users, and what permissions they have. Everything, it is being maintained in the data dictionary. And you know, the crucial and important part, when your database administrator runs this create table command, the schema definition will land on this data dictionary only. That your query that is being semantically checked, that will be checked by this data dictionary only, whether this table exists or not. Okay, so last one is statistical data. So what happens here is the database quietly maintains some stats about the data, how many records you have, how many values are being distributed. Why it is being required? Because your optimizer usually use these stats to estimate the best plan to execute, you know. So basically, when we are talking about optimizer, it is utilizing this statistical data, you know, to make the final decision. So that is the thing, students. So that is your complete all floors of your database architecture, and this is your complete database architecture where we have started. And let's see, this is your first floor: users, query processor. Now in your mind, you should get all the things that we have discussed so far about it: storage manager, and finally your basement, that is your disk storage. Finally, with this, our database architecture is done. Okay, now I will tell you certain questions that can be asked from this portion, and please make a note of these ones to prepare, you know, for your exam well. So these are certain things. Like first question that I would like to tell you is, explain the structure of DBMS with a neat diagram. This question can be asked for 10 marks directly. Second question can come as, explain the components of storage manager. These are those questions which I have taken from some previous year question papers, and this question can be asked for 5 marks. These are just certain questions which I feel are very important, and you should focus on them. Then some short questions are there, like what are different types of database users. The next one can be, what is data dictionary. Okay, the next one is, what is the role of buffer manager. So I hope you got some idea, okay, what type of questions can be asked. So if you have any doubts, please feel free to contact me. You can send an email to me. You can put some comments on this video. And that's it for this video. And one more thing, in the end, I'll give you a glimpse with by utilizing one online compiler of query language, so that you'll get the idea how things works with the database systems. Okay, so let's see very quickly. This is one query that is being written. Okay, so let's see over here what is happening here. This is one first. No need to focus too much on the syntax right now. You can just get the idea. This is one table created. This is one query which you don't have to focus too much right now. Create table. So we have created one table. So I will change certain things in this right now to show you the complete table. Okay, so this is our table. Now you can see the complete table. So here you can see it is having column names as hall ticket, name, gender, marks. So these are 3 table entries, 1, 2, 3, and we have also utilized the roll number 3 as an example. So here you can see this is one complete table frame. Now I want to get access to the data of roll number 3. The complete data should come. So what query I will write down? So the query that we have discussed, let me write it down completely for you again. So select star from student table where hall ticket is 3. So I've written this query. Let me run it, and it will just give us this complete information about that student who has roll number, hall ticket has 3. So that is the thing. So we are going to discuss these type of queries. You are going to write such queries by yourself very soon. So be connected with me and follow my lectures, and please subscribe my channel. Thank you for being a family of my YouTube channel. It is a great motivation and inspiration to me to keep running this channel. Thank you, students. So please, I'll very soon upload my next video and will very soon complete this course. Thank you for watching. Bye bye.